Okay, hi everyone. I hope this video finds you well. So today we are starting our journey with JavaFX and we are going to do some introduction and I'm going to introduce to you JavaFX terms. We are going to start off with JavaFX first application. So JavaFX is a software platform for creating and delivering desktop applications, as well as rich internet applications. It's known as RIAs, that can run across a wide variety of devices. It's also intended to replace the Swing libraries as the standard GUI graphical user interface library for Java Standard Edition. Both will be included for the foreseeable future. Since the JavaFX library is written as a Java API, JavaFX application code can reference APIs from any Java library. For example, if you have Java applications, then they can use Java APIs libraries to access native system capabilities and connect to server-based middleware applications. So the look and feel of JavaFX applications can be customized. Cascading style sheets, which are known as CSS, separate appearance and style from the implementation so the developers can concentrate on coding. So you can have two teams, one working on the front end and one working on the back end, the front end being handled by the CSS and the back end being handled by the actual implementation of your application. So graphic designers can easily customize the appearance and style of the application through the CSS. So with JavaFX, you can build many types of applications. Typically, there are network-aware applications that are deployed across multiple platforms and display information in a high-performance modern user interface that features audio, video, graphics, and animation. So the most important thing in JavaFX for you is to get to know the scene graph. So the JavaFX scene graph is the starting point for constructing a JavaFX application. It is a hierarchical tree of nodes that represent all of the visual elements of the application's user interface, and it can handle input and can be rendered. So you can have a root node, a branch node, and a leaf node. So the JavaFX API defines a number of classes that can act as root, branch, or even leaf nodes. So the JavaFX.scene, this is the package that defines more than a dozen of classes, but three in particular are most important when it comes to learning how the API is structured. The node, here is the node class. It's an abstract base class for all scene graph nodes. And the parent, this is an abstract class for all branch nodes. And this class directly extends node. And the scene class. So the scene is the base container class for all content in the scene graph. Those are the most important things you should know. So let's start with the scene graph explanation. So these base classes, the three, node, parent, and the scene, define important functionality that will subsequently be inherited by subclasses, including paint order, visibility, composition of transformations, support for CSS styling, and so on. So you will also find various branch nodes classes that inherit directly from the parent class. such as control, group, region, web view. The leaf node classes are defined through a number of additional packages, such as JavaFX shape and JavaFX.scene.shape and JavaFX.scene.text. So a single element in a scene graph is called a node. Each node has an ID, style class, and a bounding volume. With the exception of the root node of a scene graph, each node in a scene graph has a single parent and 0 or more children. It can also have the following effects, such as the blur, shadows, and all these things. Opacity, this is how solid it is, your shape. And transforms, the movement, the animations, and all these things. Event handlers, mouse, key, input methods. If you clicked on a button, for example, what happens, and all these things. And an application-specific state. So the JavaFX.scene package or API allows you to create and specify several types of content, such as nodes. And when we talk about nodes, we are talking about shapes, whether it's 2-dimensional, 3-dimensional, and so on. Images, media, embedded web browsers, and all these things. State transforms positioning and orientation of nodes, visual effects, and other visual state of content. Effects, this is simple objects that change the appearance of a scene graph node, such as the blurs, the shadows, and the color adjustments. So the UI controls, the JavaFX UI controls, this is the user interface, available through the JavaFX API, are built by using nodes in the scene graphs. So it could be like checkboxes, color buttons, the buttons we know, toggle buttons, progress bars, and all these things. So they can take full advantage of the visually rich feature of the JavaFX platform and are portable across different platforms. JavaFX CSS allows the theming and the skinning of the UI controls. These controls reside in the JavaFX.scene.control package. Documentation for controls can be found in this link. You can go to this link. This is documentation that you can find all the things you need for controls. FX controls like label buttons, radio buttons, toggle buttons, checkboxes, scroll bars, and all these things are examples of the JavaFX controls in the API. Layout. The layout containers or panes can be used to allow for flexible and dynamic arrangements of the UI controls within a scene graph of a JavaFX application. So the layout API includes the following containers classes that automates common layout models. The border pane class lays out its content nodes in top, bottom, right, left, or center regions, the H box, V box, stack pane, and all these things. Now, all these things are going to be given in a separate lecture. 2D and 3D transformations. Each node in the JavaFX scene graph can be transferred in the XY coordinates using the following JavaFX.scene.transform classes. You have translate, scale, shear, rotate, and refine. Visual effects. The development of rich client interface in the JavaFX scene graph involves the use of visual effects or effects to enhance the look and the feel of JavaFX application in real time. The JavaFX effects are primarily image pixel based, and hence they take the set of nodes that are in the scene graphs, render it as an image, and apply the specified effects to it. This is how it works. Now, some of the visual effects available in JavaFX include the use of the following classes: the drop shadow. This is rendering a shadow of a given content behind the content to which the effect is applied. And reflection renders the reflected version of the content below the actual content. Lighting simulates a light source shining on a given content and can give a flat object a more realistic three-dimensional appearance. So before we start working on JavaFX applications, you may need to add JavaFX to your Eclipse. And if you need to do that, then you need to go to Help in your Eclipse, install new software, click on it, then provided with this link, work with Oxygen, http download.eclipse.org/release/oxygen. That would give you a lot of things, a lot of frameworks that you can install into Eclipse. We are looking for the JavaFX. When you write in this text box JavaFX, it's going to give you this thing, which is what we want. This is general purpose tool, the JavaFX environment to be added to the Eclipse. You click on this one, check it, and then hit next, which is going to then ask you to restart Eclipse when it's done installing. I'm going to show you how I'm going to do that in my Eclipse. So help, then install new software, then you select Oxygen, and then give it a second to load. When it's loaded, it's going to allow you to install JavaFX, or you can directly go to JavaFX like this. You can add Eclipse, http://eclipse.org EFX updates released 3.0.0 site, and you check those two. Now I'm going to show you and then next. This is if you prefer this Eclipse directly. If you're going to look for Oxygen, it's going to take a few seconds to a minute to load. Once it's loaded, you can look for FX, and this is going to look for the JavaFX environment. Here it is. Click in here, then next. It's going to calculate requirements and the dependencies for this one. Start installing that. Once it's already installed, you can hit finish. I already installed it on my Eclipse, so I'm just going to stop this. So I'm going to show you how you start a new application. Now for new application, you can do new, then project, then JavaFX project. If you couldn't find it in here, you should find it in here after you install the JavaFX environment into the Eclipse. You can look for FX in here and it's going to give you JavaFX. But I'm going to choose this one, JavaFX project. Next. Let me just give it a name, for example, Hello World. And I would hit finish. It's building the workspace, and once it's done, it's going to finish all this thing. Okay, it's done. Let me just run it. If your JavaFX is installed properly, then you should have this window once you run your program. And here is our main class. This is the class that we are going to work on. This is the one. So let's go back to our slides. So here's how we created a new project file, new, then project, and we selected JavaFX. We select JavaFX project, and we had hello world, then finish. Here is the structure. Here it is. Here it is in here. Okay, so the application class. We are going to see the application class. The entry point for the JavaFX application is the application class. All JavaFX application extends the application class. They must also override the start method. And this is what you're going to see in our Eclipse. So you have application, and it's importing JavaFX application.application in here, and all the needed libraries. And one more thing you should notice: everything we're going to use in JavaFX must start with JavaFX. So if I'm going to have a new layout, it should be starting with JavaFX. Never import anything with anything but JavaFX. And I'm going to show you some examples once we hit an instance of it. So the application class, here's the start method. The start method takes a primary stage like this. Here is the start method. It's always going to be overridden in your application, and it takes the primary stage. And we are going to see why. So the JavaFX lifecycle does the following in order whenever application is launched. First, constructs an instance of the specified application class. This is first. Then calls the init method. This is the initialization method. Then this calls start. The start, and it takes a stage. This is what we have given it, right? We have given it a primary stage. Waits for the application to finish, which happens when either of the following occurs. You start working on your application after this point, and the JavaFX application is going to wait for you to finish. Now, it finishes if one of these two things occurred. The JavaFX application calls platform.exit, which exits the current window, or the last window has been closed and the implicit exit attribute on platform becomes true. Then if those happen, call the stop method. Call the stop method. So the code, your code should look like this, which is what we have in here. This is our code, right? And we ran it, we made sure it works. So wait a second, we have a main in here, and in the main we have launch args. So we have a launch application. A launch method. What is the launch method? What kind of method it is? So the launch method is launches the standalone application. The standalone application. This method is typically called from the main. So it must not be called more than once, or an exception will be thrown. So if you try to call launch again, you give it, for example, args again, then this is going to cause the program to fail. This is going to cause the program to fail. Now, some platforms will, like mine, will allow it to override. But then it's going to give you an exception in here because you invoked launch twice. You close the application, but then another launch is being executed, and this is what causes the application. But regularly, when you do that, it's going to launch it, you close it, and that's it. It's going to terminate without any problems. So never call the launch twice or more than once. So this is equivalent to launch, class, and arguments, where the class is immediately enclosing class of the method that is called launch. It must be a subclass of application or runtime exception will be thrown. The launch method does not return until the application has exited, either via a call to platform.exit or all of the application windows have been closed. So here is the prototype or the signature of the launch method. Does it look familiar to you? Yes, pretty much it's like main, right? It's like the main function. So you have the main function that takes the args and you pass them to launch. It's pretty much the same method with different jobs for each one. So the start method, which is the most important method in our application. This is the main entry point for all the JavaFX applications. The start method is called after the init, the initialization method, has returned. And after the system is ready for the application to begin running. So whenever the start method is called, that means your system is ready to run. Note, this method is called on the JavaFX application thread. So the start method, parameters for the start method is going to be the stage. And we usually give it the primary stage. So the primary stage for this application onto which the application scene can be set. Now, scene, stage, this reminds you of a play, right? Like Shakespearean play, where you have scene, you have visual effects, you have actors, which are going to represent your nodes, and you have a stage, all these things, right? A stage, and we change the scenes on our stages, right? So for this quarter, we are going to deal with one stage, the primary stage, and whenever we want a new scene, we can create a new scene and change the scenes. On each scene, we are going to have specific actors like nodes. And if we want to group them, we are going to use groups. And if we are going to move them, we are going to use transforms for the visual effects, for the transformation orientation of these nodes, and all these things. So the primary stage will be embedded in the browser if the application was launched as an applet. Applet basically is the Java capability of using your Java application on the web browser. Applications may create other stages if needed, but they will not be primary stages and will not be embedded in the browser. This is why we are going to use the primary stage for pretty much most of our applications this quarter. So if something wrong happened during the execution of the start method, an exception will be thrown. So, okay, let's update the start method. So you're going to delete the border pane root, and we are going to replace it with a stack pane root. This is a new layout. And then, so you're adding this, and we are adding a new title to the primary stage. So I'm going to change that to stack pane. And as you can see, it's already called the stack pane from the JavaFX all the time. JavaFX. All the time, JavaFX libraries. Because sometimes if you did not do this, this is going to be underlined, and you may get to see that, oh, do you mean a stack from java.util? No, we are not. We are actually looking for javafx.scene.layout, because the stack pane is a layout. Okay, and then we are going to add a title. We can put a title in here. The primary stage dot set title, and you can call it hello world. Here's an exclamation point, and let's run our code. So always save resources. Okay, here it is. We have a title right now. It says hello world. Okay, that's good. That's good. We tried that. We imported the stack pane. Everything works perfectly. And we tried it out. And here it is. Hello world. Okay, now the relationship between the stage and a scene. As I said, the scene is going to be set on a stage. Here is your stage. The window is your stage. What you have inside your window is going to be your scene. You can have controls like progress bar, buttons, you can have text fields and all these things. And you can have even panes, containers, or layouts, right? You can have everything on the stage, on the scene. So everything here is on the scene. The scene itself is in the stage, on the stage. So I think a stage can have many scenes. If you think of a play, the stage is decorated differently by each scene. So we are going to decorate the scene, hence it's going to be on the stage. The stage looks decorated. Each scene is made up of many things. So the stage class, the JavaFX stage class, is the top level JavaFX container. The primary stage is constructed by the platform. Additional stage objects may be constructed by the application if needed. Stage objects must be constructed and modified on the JavaFX application thread. Many of the stage properties are read-only because they can be changed externally by the underlying platform and therefore must not be bindable. We are going to see what is binding in one of the lectures of JavaFX lectures this quarter. So the stage style. The stage can have one of the following styles. Stage style dot decorated can be decorated. The stage with a solid white background and platform decorations. This is what we just had in our application when we started. This is pretty much the default. Undecorated, a stage with a solid white background and no decorations. Stage style transparent, stage with transparent background and no decorations. Utility, a stage with a solid white background and minimal platform decorations. So the style must be initialized before the stage is made visible. On some platforms, decorations might not be available based on the platform you're running your JavaFX application on. For example, on some mobile or embedded devices, In these cases, a request word created or a utility window will be accepted, but no decorations will be shown. So the stage object is often the window. The stage object will hold a scene object, and a scene object will have a tree structure of a node objects like this. Branch nodes can have children nodes, so this could be a group of another leaf nodes, and leaf nodes do not have children nodes. So the scene class, scene object will be a tree structure of node objects. Branch nodes can have children nodes like layout managers, a group of nodes. Leaf nodes should be some kind of GUI objects or shape objects because they don't have children. Layouts, there is a separate lecture on layouts. Layouts are parent nodes that will help position where the children nodes will be positioned. There are many different layout classes, as we said before. Stack pane, H box, this is the horizontal box. V box, items will be aligned vertically. Vertical box, flow pane, those are going to be flowing on the scene like flowchart and these things. Border pane, grid pane, tile pane, anchor pane. We are going to try these things in a separate lecture. Stack pane, this is the one we are using today, will build a stack of children. The first child is put on the bottom, and the later child or little children will be put on the top. These children will be centered by default, but this can be set for each child. So we are going to update the start method. So we are going to change the title to stack pane example, and we are going to make it looks like this code, which is pretty much just changing the title, right? Changing the title. So change the title to stack pane example. So stack pane example. Okay, this is the first thing, the stack pane as our root node. Then we are going to add a JavaFX text object. Now, always remember that the Java docs are your friend. So always read from the Java docs if you struggle. How it's being used, here it is. You need to import javafx.scene.text, and you can use text and all these things. You can learn a lot from Java docs. Okay, so the next step is going to be we are adding a text object. We are adding a text object. So let's add a text object. So we can add it in here. Text equal new text, and I'm going to give it a text to show on the screen. I'm going to call it simple or simply \n, which is going to add a new line, then amazing. Simply amazing. And when you hover your mouse over here, it says that you need to include a library. But wait a second, which one to import? Is it javafx.scene, javax.xml, or org.w3c? No, always import the one that starts with JavaFX. Most of the errors you would have because you imported the wrong library. You imported the long library. So, okay, here it is. Then we're going to add a text alignment. So text, or variable name, dot set text alignment, and I'm going to set the text alignment to center. So text alignment dot center. And as you can see, the text alignment also from JavaFX. And then I'm going to add a font. What kind of font I'm going to use? So set font. And for font, I'm going to have that from font dot font, and I'm going to give it the font name and the font size. The font name I'm going to use is Comic Sans MS, and the size is going to be 36. So let's try it. Is it going to show on my screen? Oh, still empty. Still empty. So what is the next thing? What is the next thing? The next thing is to add it to the root. Because right now we created one, but we haven't added to the root. So root dot get children dot add, and I'm going to add the text. Now it's going to show on my screen. Okay. Now here it is. So nodes and shapes. A few child classes of shape. Arc, circle, cubic curve, ellipse, line, path, polygon, all these things. Some properties would be fill, opacity, and stroke. Fill, the color of an or effect that the shape is filled with. Opacity is how solid is the shape. So can you see through it? 0 invisible to 1 completely visible. Stroke, the border of the shape. This can be said to be inside or outside the shape. Here is an explanation of opacity, fill, stroke. So go add circle, the circle to your object. And when you add the circle, set the fill, the color, to blue, color dot blue, and set opacity to 0.6. And when you add more than one child, you need to use add all, not just add. So I'm going to just try this. So I'm going to add a circle equal new circle, and I'm going to give it the radius. So if you want to know what to give it, JavaFX is always your to go, right? So this creates a circle, but if I give it like 50, now this is going to use another constructor. It's going to be the radius. So I'm giving it the radius. I'm going to set the color. So set fill is setting the color of the background of this circle. So I'm going to give it color dot, let's give it a blue. Now, whether blue in all caps or lowercase, doesn't matter that much. So the set fill is not applicable for type color. Why is that? Let's try to make it blue, and it says that So if we look in here, here's an error. Here's the type of error that I'm talking about. We thought that, okay, everything works perfectly, but wait a second. What is this color? It's from java.awt. What we need is the one from java.fx. So delete this one and hover over the color in here and import the one that is from javafx.scene.paint. This one is going to work. Now I'm going to also finally set the opacity. So circle dot set opacity, and I'm going to give it 0.6. And as I said, we are going to add all when we add more than one object. So first we are going to set the text, then circle, try it. If you're adding more than one object, you must use add all. Here it is, circle and object. So let's go back to our slides. Here it is. So now you go yourself, add rectangle, set the fill for the rectangle, set the stroke, what kind of borders you want, and what is the stroke width, the border's width, and add it to the root. You do it, and here it is. Wait a second, where is our circle? Where is our text? Okay, so here's a fact. Always the order matters when you use a stack pane. When you use a stack pane, remember what you have on the top, what you have in the back. So always the bottom, the top, what's in the front, what's in the back, you have to take care of these things. So what does it do if we put rectangle after text? The rectangle after the text. So here it is. Here it is. So we have the text, the circle, and the rectangle. If we try it. So you do that and see the effect of each thing. So will the text be visible if we have this in here? I'm just trying the text and a circle. Yes, it does. But if this is 1, is it going to show the circle is in the back? Is it going to show? Yes. But what if we put this in here and the stroke for the circle is 1? So it's going to blind part of the text because, as I said, it depends on which one is in the top and it depends on the opacity and all these things. So you add a rectangle, try it on your own, and here is the result. So something called Z-order, which is an ordering of overlapping two-dimensional objects such as window in a stacking window manager, shapes in a vector graphics editor, or objects in a 3D application. One of the features of a typical GUI is that windows may overlap, so that one window hides part of another. Z order in JavaFX is actually the order in a scene graph. For example, the content sequence of the scene. This is what we have seen in here, and then we fixed it when we changed the order in here, right? So the last thing you would do is you would put the order back to the way it was, and bam, seems nicer in here, right? Seems nicer. So one exercise for you is, can you make it looks like this? Like the radius of the so the rectangle, when we added the rectangle, we added 150 and 150, and the circle radius was 50. Can you do your calculations so the radius of the circle will make it like this? Now, this is something you should try. you do it on your own and you upload it to the assignment page where I'm going to say exercise assignment page or something like that. Have a good one and catch you in the next one. Peace.